Let's talk about what the graphs of some exponential and logarithmic functions look like. So here we go. Now you can use Desmos. However, I think for the sake of explanation and understanding what all the nuances are, that we should graph some of these by hand, and then we'll go to Desmos in a few minutes. However, I also want to point out that if you were to scroll down, you're going to see some words and some phrases that you haven't seen before. So we're going to discuss those as we get there. But in the meantime, let's just start making up some numbers. Let's suppose I wanted to figure out what happens at 0. I put it there strategically. And I would say, well, 2 to the 0, which of course is 1. Okay, well, no big deal there. So let's just kind of stop right there and start answering some questions. If I was going to graph this, which I am about to do, I would put a point at 0, 1, and that actually answers the very first question. What is the y-intercept? If you ever want to know an intercept, whatever intercept it is you were looking for, then you need to plug in 0 for the other one. Here's what I mean. For the y-intercept, x equals 0. So if I'm asking you for the x-intercept, then y is going to equal 0. And you'll see what I mean as we go. But in the meantime, here goes. Here's my answer for this one. It is going to be at 0, 1. Let's keep going with the table here. If I plug in a 1, I have 2 to the 1, which is 2. If I plug in a 2, I have 2 to the 2, which is 4. If I plug in a 3, whoa, extending the table, I'd have, that's a good straight line there, isn't it? 2 to the 3rd, which is 8. And so we can plot some points. Let's also go backwards. Let's go to -1. And if I go to -1, then I'd have 2 to the -1, which actually puts 2 to the 1 in the denominator. So what I really have here, let me get some scrap paper. What I really have here, just feel like explaining this. If I had 2 to the -1, I really have 1 times that, right? Okay, so this is all one big fraction right now. And that big fraction is just numerator. Well, this numerator stays and this goes to the denominator. So I'd really just have 1/2. You don't have to write all that. So let's plot some points. Let's see what this thing looks like. And you know what an exponential function looks like. And you know what this one looks like. We've actually done this exact same example in a different lesson, but we are just expanding our vocabulary and just talking about the different nuances here. So let's see. 0, 1, 1, 2, 2, 4, 3, 8, and let's back up a little bit. -1, 1/2. Okay, well, let's keep backing up. And as we keep backing up, we could continue making this table. And making this table would look like this. If I had, let's go -4, -3, -2, and so here's x and f of x. And if you're just watching this part of it and you're not writing these down, that's okay, because I'm trying to prove a point, but I think it would be handy to have it. So let's work our way up. So if I had 2 to the -2, well, let's see, that would be 2 squared in the bottom, 1 on the top. So that'd be 1/4. Okay, so let's plot that point. -2, 1/4. That's hard to plot. And then if we do this one, we'd have 2 to the -3, which would give me 1/2 cubed, which is 1/8. All right, well, so we're going to go back to 3 and then 1/8, which is even closer. And then we're going to go to -4, and that gives me 2 to the -4. You know where this is going. And we've done this exact same example. Let's just jump straight to it. That's 1/16. So 1/16 is really, really close. So if I was to connect these dots, it's going to be very hard for me to really make it look exactly the way it should look. Whoa, that's the wrong color. It's supposed to be red, isn't it? If I was going to connect these dots, then we'd have this, and we'd have hopefully a smooth curve. And this smooth curve is going to get closer and closer and closer to the x-axis, which again is very, very difficult to draw. And it's never actually going to touch the x-axis. So if I could draw this correctly, then we would never ever touch the x-axis. And you can kind of see that. So let's take a look at these fractions. 1/4, 1/8, 1/16, 1/32, 1/64. And these fractions are going to get closer and closer and closer to a value of 0, but they're never going to reach it. Okay, so let me tell you where this is going. We're headed towards that word right there. That's where this is going, but we'll get there in a minute. Let's just tackle some of the easy stuff first. Is this function increasing or decreasing? Well, as I look from left to right, my function is going up. This is one of the easier questions. So my function is going up, therefore my function is, well, increasing. Increasing. Oh, I wrote it in red. I've been trying to write my answers in blue consistently, and I have not. Oh well. What are the domain and the range? Let's switch colors. Let's make it purple. Why not? So domain, range. The domain of this function is from negative infinity to infinity. Now, you've done this same problem before, so let's not waste too much time. The range does not include anything in the negatives, and it starts at 0 and goes up, but it actually does not include 0. So again, we'll never ever get this to equal 0. So it's from 0 to infinity. And then we have this awkward question that we don't know how to answer yet. So what is the end behavior? Well, the end behavior is how the end of this thing behaves, how each end of this thing behaves. So we're going to actually discuss the end behavior from two different perspectives. We are going to approach going towards the left, and we're also going to approach going towards the right. So this is going to look kind of common sense, and they're not always common sense, but here goes. So as I am going to the left, I'm approaching the left. Well, as I'm approaching the left, like my x values are going towards what? Well, they just keep going down and like more negative and just negativer and negativer. So as x approaches negative infinity, y approaches, and it is totally okay to use the arrow for saying approaches. That's actually a mathematical symbol that we will use, and it's completely okay to do so. So as x approaches negative infinity, y approaches, okay, so what's the y doing? Well, the y is getting closer and closer and closer to, well, 0. So y approaches 0. It never reaches 0, but it gets close to 0. Okay, let's go to the right this time. So as x approaches, well, if we're going to the right, then x is getting much bigger, so it's going to approach infinity. Y approaches, well, let's see. What's going to go up and up and up and up and up and up and up. So as it goes up, that up is going towards, well, infinity. So y approaches infinity. All righty. Let's talk about this funky word right here. What is the equation of the asymptote? Well, I need to give you a definition of an asymptote, and I will do it in red. What is the equation of the asymptote? An asymptote is a line that a graph approaches but does not cross. Okay, so later on when you become a professional mathematician, you're going to realize how wrong that definition is because there are some asymptotes that actually do cross, and we can kind of pick apart the specifics of the definition. However, for the sake of this lesson, this is a very good functional definition. So we're going to approach a line but not cross it. So we are approaching, and we're going to draw it in green. I'm going to draw it in green. I haven't used green yet. We're approaching this line right here. This line actually is the x-axis. We are approaching the x-axis. So as we approach that line, we are getting closer and closer and closer to it. Well, I need to know what the equation of that line is. Well, what's the equation of the x-axis? Okay, well, it's a horizontal line. Horizontal lines have an equation that say y equals, and this particular line, this horizontal line, crosses the y-axis at 0. So it's y equals 0. So there is our asymptote. Now we're about to move on to the back side of this, and as we go to the back side of this, you're going to notice something that's fantastic and amazing, and that fantastic amazingness will take place on some scrap paper. So before I flip the paper over, I want to show you something that we're about to do with this, and we're not going to do this on any other problem, but we are going to do it on this one. So here goes. If I gave you this graph right here, or if I gave you this function, which I'm just rewriting what's already there, and I said find the inverse, and you don't have to write this, although I don't know why you wouldn't want to. If I said find the inverse of this, then I would switch x and y, and I would have that. And then we're going to solve it for y. And when we solve it for y, we're going to, well, oh my goodness, if we're solving for an equation that has a variable in the exponent, we need a log. Log base 2 of x equals y. And it's a little backwards looking from what we see, but the numbers do go in the right place, right? Okay, your exponent is your answer. It equals that. And here's your base, and then the other number goes here. And so the inverse is log base 2 of x. Okay, why am I telling you that? The inverse of 2 to the x is log base 2 of x. Let's flip the paper over. if I could. Now, I've unstapled mine so I can flip it over a little bit easier. Sketch the graph of the, oh, wait. That's the inverse of the first problem. Most of our work is done for us. That's beautiful, okay? I'm going to actually kind of write that down, and we're just going to say that this is the inverse of f of x equals 2 to the x. So everything we did on the other side of this paper is going to come in really handy here. For example, every coordinate that we graphed is going to be reversed on the backside. The domain and the range are going to be swapped. These are going to get a little trickier. We are going to have an asymptote that we'll be able to discuss. Let's start by just reversing some points. So just holding it in our head as we flip back and forth from one side of the paper to the other. The original function was -1, or had a coordinate at -1, 1/2. So this one's going to have a coordinate at 1/2, -1. The original function was at 0, 1, so this one's going to be at 1, 0. The original, you know where this is going, right? Okay. The original was at 1, 2, so we're going to go 2, 1. Or 2, 4 becomes 4, 2. We're reversing the x's and the y's. So 1, 2, and then 2, 4. And 3, 8 if you want to get crazy and extend this thing. And if you want to do the same thing you did over here, which we are going to do, then we would have, what was it, -4 here, and that was 1/16. And then we're going to have -3 here, which was 1/8, and -2 here, which was 1/4. Yeah, that's what we had. And we're going to plot these points. We're going to plot all of them, actually. And when we plot all of them, we'll be able to see what the inverse of this looks like. And we, again, have done this exact same problem before, but now we're really going to talk about what all this means in terms of end behavior and the asymptote. So we're just expanding our vocabulary and expanding our understanding of this. Okay, 1/2, -1, 1/2, -1 goes there. 1, 0 goes there. The pause right there. Let's stop right there. Do you know what you just did? You just crossed the x-axis, and this asks for the x-intercept. So if I want an x-intercept, then y equals 0, right? Okay, so if you're looking for a y-intercept, x equals 0. If you're looking for an x-intercept, y equals 0. And it makes sense. I mean, look at where you are. You're sitting right here on that dot, right there, and the y value is 0. So if you ever need to know where you cross an axis, plug in 0 for the other value. If I need to know where I cross the y-axis, then x is 0. If I need to know where I cross the x-axis, y is 0. Okay? So the y-intercept is where x is 0, so the actual answer for this, which I shall write in blue, is going to be 1, 0. That's the coordinate for it. Okay? We kind of saw that in the table. All right, let's keep plotting points. I sidetracked my point plotting. 2, 1, 4, 2, 8, 3. And we see we've got this graph, and it's going up, and it's doing this thing, and it's just going to keep on going up for days. It goes up forever. Now, it doesn't go up very quickly, but it goes up forever. Let's plot some of these points, though. 1/16 and -4. 1/8 and -3. 1/4 and -2. What? Okay, so here's the deal. We're going to get super duper close to the y-axis, but we're never ever going to cross it. Oh, looks like an asymptote to me. Okay, let's answer some other questions, then we'll get down to it. All right, my answer's in purple. Let's go purple. These multicolored things are probably driving you crazy. Is the function increasing or decreasing? As we go from left to right, the function is going up. So this one is increasing. Okay, what are the domain and the range? Don't think about it. Really, don't think. Reverse those. Now, if you want to think, you could. Because the domain goes from 0 to infinity, right? Oh, not a coincidence. The range goes from -infinity to positive infinity. -infinity to positive infinity. Okay, end behavior. This one's going to take a minute or an hour. And then people skip to the video. Okay, well, what is the end behavior? Well, we're going to go to the left, and we're also going to go to the right. And you do not have to write left and right every time, okay? I'm explaining what's going on. I'm actually going to start with the easy part. Let's go to the right first. I think that one's going to be easy. As we go to the right, x is approaching infinity. So like we're going, oh man, x is getting bigger and bigger and bigger and bigger and bigger, and it's just going. So as x approaches infinity, infinity, y approaches, okay, so as I'm going to the right, what's y doing? It's going up, okay? It's going up now. It's going to the right, but it's going up. It's going up slowly, but it's going up. So it's approaching infinity. It's not approaching infinity very fast, but it's getting up there. Okay. But as x approaches, all right, do not put negative infinity, and here's why. As I am coming this way, coming from the right to the left, I can't approach negative infinity. My graph stopped right there. I can't go any further. So as x is approaching, well, okay, well then how far did it go? As x approaches, well, it stops here because it keeps going down there. It stopped at x equals 0. So as x approaches 0, but here's the deal. I can't just say x approaches 0. I'm going to say x approaches 0 from the right. Okay, because if I want to approach 0, who's to say I'm not coming at it from this side? But I can't come at it from this side because there's no graph over here. I have no choice but to approach 0 from the right to the left. So as x approaches 0 from the right, y approaches, okay, let's think about it. As we get closer to 0, what's happening? The graph is going down, like way down real fast. So y approaches negative infinity. Okay, what's the equation of the asymptote? Where is the line that you get really close to but you never cross? That would be the y-axis, my friends. Now you could say y-axis, but actually it asked for the equation of this line. And in wanting to know the equation of the line, well, let's find out what the equation of this line is. It's a vertical line. Vertical lines have an equation of x equals something. So x equals what? X equals what? Well, I cross the x-axis at 0. So there's my asymptote. Okay. I'm going to stop the video here, and then we will go through the other examples in the next video.